Well, good evening, everybody, and welcome to our September webinar. It's awesome to be with all of you guys tonight. As always, we've got a pretty awesome evening put together with about the first 30 minutes of this presentation being our kind of our normal monthly tips, what's going on in hives. And then our last hour, we've given over to Randy Oliver, who, as many of you probably know, is really a world-renowned speaker in the beekeeping world. And what I love about Randy is that he is incredibly good at taking scientific research and a lot of the scientific research that he does and boiling it down to lay terms and a lot of practical application. And so Randy later tonight is going to be going over kind of all of his latest research into very practical things like thermal treatment for Varroa mites and pollen patties and things that we can take out tomorrow and apply in our own beekeeping operations. So pretty excited about that. We're going to go through everything at a pretty rapid pace tonight, the first 30 minutes, because we want to make sure Randy has a full hour. So I'm going to move along pretty quickly, and we're not going to do our normal 20 minutes out in the bee yard at the beginning just because we don't have the time. Instead, we'll be watching a couple videos out in the bee yard during the course of my 30 minutes to talk about what's going on out in the bees. So with that, let's keep rolling. The fall blooms are right around the corner. So we're still kind of seeing the remnants of the summer flowers that are, some of them are starting to die off. And over the next month, we'll begin to see fall blooms, which is so exciting because that is a sudden boost of nectar and pollen for our bees, which really helps them prepare for winter. Up here in the upper right, we've got our snow on the mountain or snow on the prairie, depending on what part of the state you come from. And that is certainly in full bloom right now. The summer rains in general across much of the South have really made the snow on the prairie bloom beautifully this year. And so that's doing awesome. The other plants you see here aren't blooming yet, but will be coming into bloom, in the next 3 weeks or so. You've got your broomweed up here on the upper left, which is an awesome fall plant for the bees. The white aster on the lower left is an awesome one as well. Of course, everybody knows about goldenrod. As much as our allergies hate ragweed and goldenrod, the bees absolutely love it. It often gives if you walk out into your bee yard late in the evening when the ragweed or goldenrod is really blooming heavily, you'll kind of smell this kind of strange musty smell out in your bee yard. And it's actually that goldenrod nectar in your hives that the bees are evaporating the water out of it to make honey, and it kind of gives off this kind of strange musty smell. So and then of course the far right is the purple thistle, and that'll be coming into bloom in a couple of weeks as well. So kind of along with that, what are we seeing out in the bee yard right now? September is what I consider the beginning of the end of bee season. And I'm kind of sad. I mean, I don't know how it happened so quickly. I just feel like the summer flew by. And, September, though, truly, even though it's still hot outside, September really is the beginning of the end. We don't have a lot of time left to really work our bees before they really are going to be shutting down for the winter. The fall nectar and pollen trickle should begin late in September and be in full swing in October. Usually like, late September to, mid to late October, depending on how cold it gets in October, is when we kind of see that peak fall flow, if you will, in most of the state. And we continue to get occasional rains. So I'm really optimistic that this fall is going to be a pretty awesome fall flow. I know I talk about Varroa all the time, so I'm not going to get into it too much other than to say September is your final window to do something about your Varroa mites, whether that's a chemical treatment, a natural treatment, mechanical treatment. If you're going to do something with your bees and the Varroa mite levels, this is your final window. Do get that done in September. At the very least, test and make sure that you're testing your hives to see if you have a problem that needs to be addressed or not. If you haven't treated at all this year and you intend to treat, you definitely want to get that done Even if you treat it in July and think, okay, I treated my bees in July, so no problem, you might need to check them again because those varroa mite levels are pretty pesky about ramping back up. These are just a testing rules. We've been over them before, so I'm not going to spend a lot of time on it. But in general, I recommend testing your bees for varroa mites every 1 to 2 months, March through November. If the mites are over 2 per 100 bees using an alcohol wash, you need to take action. We have a great video on our YouTube channel and on our website about how to do that alcohol wash and the directions on how to do that. You can also use a sticky board, and if you get more than 10 varroa mites in a 24-hour period using that sticky board, you need to do a treatment as well. I'm going to jump over really quickly to Jamie Ellis, and I really enjoy what he shares with us on varroa mites and, well, the most common cause of death in hives. Let's see what Jamie Ellis considers that to be.
So everyone on planet Earth has heard that bee colonies are dying. When I tell people I'm a bee scientist or a beekeeper, the first thing they ask me, are bees really dying? And number two, what's killing them? Right? So everyone then takes the next question. Well, Jamie, what do you think is the most significant threat to honeybee health? And I know if you're watching this, you're going to have read all types of things. You're going to have heard all types of things. You will have been told all types of things. But I don't care what you've read or been told. The truth is, Varroa and the viruses it carries collectively act as a single thing that is the most significant killer of bee colonies. In my opinion, beekeepers lose more colonies to Varroa management related issues than anything else they could control. Not only does Varroa, this mite that get on the outside of the bee, feed on bee fat bodies and compromise bee immunity, but it also transmits viruses that themselves are terrible for bees. You put Varroa and the viruses together, and you have dead bees. This is how I usually explain it. The viruses by themselves are a minor nuisance. Varroa by itself is a minor nuisance. When you put those viruses and Varroa together, your bees are going to die. It is of critical importance that beekeepers, all beekeepers of all operational sizes, know how to spot problems with Varroa and know how to address them adequately. In my opinion, beekeepers woefully under address Varroa. And because of a lot of misinformation out there, they'll attribute their colony losses to nearly anything else except Varroa. Usually when people tell me, hey, Jamie, I had my bees die, blah, 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 the first thing I ask them, well, what was your Varroa treatment? When you sample for Varroa, what were your Varroa populations? If they cannot tell me those answers, then it really doesn't matter what comes out of my mouth. What's in my head is Varroa killed that beekeeper's colonies. Now, I've seen people try to blame everything else, but oftentimes it boils down to Varroa. So, in my opinion, the principal killer of honeybees, the number one killer of bees, at least in North America, honeybees in North America, is the mite Varroa destructor. So we as beekeepers need to do our part to try to address that mite and its populations in our colonies.
Perfect. Thank you so much. So, and Dr. Ellis, obviously feels very strongly about varroa mites and the cause that they are, the effect that they have on your hives. So we actually have a whole 2 or 3 hour long presentation speech that you can view on our website. So if you go to our website and go down to virtual advanced classes, you can actually watch 2 or 3 hours where we went over specifically how to handle varroa mites. We don't have time to go over that today, but it gets into all the nuts and bolts from an organic, natural, or chemical perspective of how to handle varroa mites. So September, as far as feeding goes, September is when we began to transition from trickle feeding to winter feeding. And what that looks like is I recommend feeding as much pollen substitute as your hive can eat now through November, ensuring that they eat everything in approximately 1 week, and then give them a couple days and then give them another pollen patty. A good strong hive should be eating 2 to 3 pounds of pollen substitute per month. And as far as sugar water goes, if your hive needs syrup, then you can feed 1/4 to 1/2 gallon per week of 2-to-1 syrup. So we've switched away from 1-to-1. We're now doing 2-to-1 through September until the hive has 30 pounds of stores in the second brood box. The 1st of October, if they still don't have 30 pounds stored in that second box, you can start feeding them a gallon per week until they've got 30 to 40 pounds stored. Your objective is to get them to where they have 30 to 40 pounds in that second box before about mid-October, because after mid-October, the bees are really not going to drink syrup much at all. It starts getting too cold, and they don't drink and store syrup nearly like they will this time of year. So get to that 30 or 40 mark. Remember, a medium box completely full, 100% full, is about 40 pounds. A deep box completely full is about 60 pounds. So that kind of gives you a bit of a point of reference as to the stores you're going for. If you already have that on your hives, don't worry about feeding. A lot of hives don't need it. But if your hive has less than that, go ahead and consider it. What do bees actually need to survive winter, which is where we're coming up on? It depends a little bit on where you are. This picture was actually, you can't tell, many years ago at this point, in New Brunswick, Canada. And this is how they overwinter their hives. And usually the snow is up over the tops of the hives and you can't see them at all. But they bundle them up and wrap them up and put candy boards. And, they need a lot more than 30 to 40 pounds of honey to overwinter. Here in the South, 30 to 40 pounds is enough to get most hives through the winter. You also need your mites to be under control, under 2 per 100 bees, sufficient bee population, which we'll talk about in a bit, and a healthy laying queen. Keep in mind, as we're talking about feeding pollen substitute and syrup, especially pollen substitute, remember the concept of fat bees versus skinny bees. The more nutrition a hive has, the more fat stores are built up in their body, and the more easily more successfully they'll overwinter. And so we're kind of entering the final stages of winter bee rearing. So the baby bees that are being reared right now in your hives are the ones that are going to have to live throughout the whole winter and start the colony going again in the spring. And so it's important that those baby bees being reared right now have a very nutritionally complete diet. Otherwise, your hive may not make it through the winter because those bees don't have the longevity needed. So that's why I really recommend feeding, pollen substitute, throughout the fall and through November. Some hives don't need it. Some it's not going to help a whole lot. Others, it's going to be the difference in between them surviving and not. What I encourage a lot of folks to do that are skeptical about feeding pollen substitute, because there's certainly, understandably, folks that think that, I shouldn't feed my bees at all. I always tell them, do an experiment. Take half of your hives and give them pollen patties and syrup, and then the other half don't, and just see long-term who's doing better. So let's jump real quick to, I filmed a video out in our bee yard about when to stop feeding. And hopefully you'll find this helpful on kind of taking a look at a hive that doesn't need any more food.
Hey everyone, let's talk about overfeeding hives. So we spend a lot of time talking about feeding, right? In the springtime, feeding to get your hive to the strength it should be. In the summertime, feeding our hives to make sure they don't starve to death. We talk a lot about feeding syrups especially. Now pollen substitute, you can't really overfeed, but syrup, there are times where you should slow down on the feeding. So let's take a look at this hive. This is a hive that doesn't need to be fed anymore. And an alternative is you can always add additional boxes. So you either need to stop feeding in some cases, or if those top boxes are completely full of honey or syrup, you got to add another box. So let's see what's going on in this hive and talk a little bit about when to slow down or stop feeding. There's a small hive beetle, by the way, if you haven't seen them. The most satisfying crunch in all of beekeeping is that little crunch right there. Love that. So Okay, so right off the bat, we can see this is a really, what I would call a really good, strong hive. You know, when I can see the top is completely covered with bees, that's a great sign. This is a box I would say is 100% full of bees. You can see there's bees between the frames, wall to wall. So I'm gonna give them a little bit of smoke. Get those bees to start running down. And I can see again right away, they've got honey or syrup stored all the way to the outside frames. Totally full, completely packed. Look at that. Now, if you've been feeding heavily, this could be syrup. In this case, it's honey, but if you've been feeding heavily, it could be syrup. So this top box is completely full, wall to wall. So definitely would need to slow down the feeding in a one that's this full, or you could add another box if you want them to, say, draw out foundation for next year, or if you're right before the honey flow starts, say in early May, then you could put on your queen excluder and you could add your honey super. But in this case, we're in the summer, and so if it were me, I would probably add another box and keep feeding maybe a fourth a gallon or so per week and get them to draw out a second box. If you don't want to keep feeding, you could just stop feeding a hive like this because it's completely full. I want to go into the bottom box and take a look at one more thing, because there's one other thing that I get a little bit concerned about that we want to watch for. So we're going to pull this second box off, set it aside, take a look down here, because one thing I really do not want to happen is I don't want my hive to get what I call honey bound or syrup bound. If you're feeding too much, they can actually fill the brood nest with honey instead of with brood. They'll kind of start reducing down the amount of space that the queen can lay. You see, we're kind of making a mess of honey. There's so much honey in here. And so yeah, so this is a little bit concerning. It's not too bad, but you can kind of see they've shrunk down the brood nest area a bit with honey. And every open cell around this brood is full of honey or syrup rather than brood. So we'll set this frame aside a little bit. Let's take a look at another frame. See, there's just honey rolling all over these bees from breaking these frames apart. So again, you kind of see there's a whole lot of capped honey around this brood. They're not filling in too bad on this frame. I'm trying to find a frame to show you an example of what I'm talking about. But you'll see in extreme cases where everywhere there's an open cell, anywhere in the hive, they filled it with nectar or honey or syrup instead of brood. You can kind of see that here, where they're just filling every available cell. But in general, they've still got a lot of great brood in here. So this hive isn't really too bad. It's not a case where they are completely honey bound. I would say that they are on the verge, but they certainly are not honey bound. So again, this is a great sign. So you've got in the middle of the brood nest, you've got open cells that the queen is laying eggs and larvae in. So they are allowing her enough space to continue that laying. Kind of in here, you can see they're starting to do that a little bit. In all these open cells where you should have brood, they've put, you can see that uncapped nectar or honey or syrup in these cells. It's not too bad, but sometimes you would see this whole frame that way, where every open cell is nectar instead of honey. And you don't want to see that in the middle of the brood nest. On those outside frames, it's okay, but it's not something I want to see in general. So again, with this hive, it's not too bad, but I definitely want to stop feeding them, or I want to add another box so they've got more room, because I don't want them storing all that syrup down here in this brood nest. Otherwise, they'll restrict the area where the queen can lay, and we don't want that to happen. So for other videos, you can always check out texasbeesupply.com, and for now, we're going to go check a different hive. Thanks.
Okay, so this is just to reiterate a little bit what may have been hard to see in that video, but this picture on the far left is a great example of a hive that's kind of backfilling the brood nest because of overfeeding, or they've run out of room and they're bringing in nectar. This is not what I want to see in the middle of a brood nest. What I'm looking for is more what's on the far right, where you've got a nice band of honey around the frames, but plenty of open space or cap brood there in the middles. So a couple quick other notes before we jump to Randy. Fall pollen substitute, we discussed that a little bit earlier, but these pictures just show placement. And I usually put pollen patties in between my two brood boxes. You know, if they're this strong of a hive, you could put 2 at a time because they'll eat it in a week to 10 days. And like I mentioned earlier, as we were talking about fat bees and skinny bees, you know, pollen patties for me really act as insurance to make sure that those developing larvae that are going to have to overwinter have all the nutrients they need in order to successfully survive the winter. Another quick note as we head into fall and winter is that the configuration of your hive, and we'll talk about this a bit more in October, but when it comes to brood boxes, ideally in September, you're going to have 2 brood boxes and 1 empty super on top of those 2 brood boxes if both of your brood boxes are mostly full. And that's just a bit of a heat barrier because it's still going to be awfully hot through September. And then in October, if that top box, that third top box isn't full of bees, then and stores, then we'll often remove that. And we'll talk a bit more about that in October. Fixing weak hives. Keep in mind, you know, last month we talked about this a bit, but keep in mind that we only have 1 to 1.5 months left of growing season for our bees. You know, like I mentioned earlier, you know, mid to late October, things really start shutting down in our part of the southern US. So now is kind of your final opportunity to boost up the strength of hives if they need it. Now, keep in mind, this chart I find helpful to show when it's not worth boosting those hives up and their strength. You know, in my opinion, if you're into September and you've got a hive that is less than 4 frames of bees, that's about when it's time to consider consolidating it with another hive. Certainly 3 frames of bees or less. If it's a 4-framer and the queen is laying like crazy and maybe it was a late split and they're growing well, they might pull through. But certainly anything less than 3 frames, I would go ahead and combine it with another hive. How to save a weak hive. You know, I mentioned a weak hive a couple of times, and the best way to save a weak hive, if it's kind of teeter-tottering on the edge and you've got 4 frames of brood or 4 frames of bees, you can add a frame of brood from a stronger hive. You can add bees. We've talked about how to do that on previous webinars. Make sure your varroa mites are under control. Feed syrup if they need feed. Feed pollen substitute, and give them probiotics and essential oils. Now, this is if you really don't want to lose a hive, and this might or might not work. You know, commercial beekeepers, we oftentimes just, you know, at that point, stack them up and move on. But if you've only got 2 beehives, you know, you might really want to work hard to try to save one of them if it's weak. And so you can kind of go through this list and do those things to try to save it if it's, you know, 4 frames of bees or more in September. And we're going to skip through some of those final videos just so we stay on track here. A couple quick side notes: remove queen excluders. So if you haven't already done that, make sure you go ahead and remove queen excluders because we don't want them on over the winter. It's not time for entrance reducers yet. You want to wait until the daytime temperatures are consistently in the 60s. So that's usually when most folks put on entrance reducers if you're going to put them on. So, okay, so with that, Randy asked for at least an hour, so I'm going to turn it over to Randy a few minutes early in order to give him plenty of time. A couple quick notes before we go to Randy is if you have questions about just general beekeeping topics like we usually answer, keep putting those in the Q&A box, and James and Sherry and myself will keep answering those general beekeeping questions. If you've got a question specifically about what Randy is addressing, just preface it with Randy, and that way we'll know to ask Randy that question or get him to answer it at the end. So with that, Randy, if you're with us, feel free to take over and share your screen if you need to.
You need to, it says you cannot start your video because the host has stopped it.
Okay, well, we can fix that.
Great.
There you go. You should have control now.
Okay, let's try it now. There it goes. All right.
Fantastic.
How you doing, Blake?
Good to see you, Randy.
Yeah, you too. All righty. So tell you what, let me show you first here. Go to this and slideshow from beginning. All right. I've got way more to share than we're going to have time for. So I need a kind of somebody to give your opinions. Which ones of these you're interested? This is a short one. This one's a relatively short one. This is a long one. That's a medium one.
Randy, we can't see your screen. I'm sorry.
You can't. Okay.
No, we can see you and your background, but we're
Okay,
not.
hang on a second. Let's try this again. Back to Zoom. Zoom. Oh, I see what's happening. There you go. My mistake.
Perfect. Nope, now we got it. Thank you.
Okay, slideshow from current slide. Okay. Okay, so these are all different research projects. Short one, a long one on the pollen subs, medium one here, a short one on thermal treatment, medium on Varroa control, and a long one on updates on extended release oxalic acid. So you can call it Blake, or if there's a show of hands, but
yeah, people are putting some in the chat box. So it looks like we've discussed the testing liquids for mite washing based on your research before.
Great.
So we've covered that one, and it's a pretty even mix on everything else. So I would say maybe start from the top and skip
okay.
Skip the mite wash and see what we can get to.
So we probably should also the thing is the pollen subs, the Varroa control, and the extended release oxalic acid. We wouldn't have time for all three of those.
Okay. Well,
So,
maybe if you can start on the first couple, and then I'll do a little poll in the chat box while you're going on which of those last three you mentioned to do.
okay, so I'm going to put these up here as questions that I get from beekeepers, or sometimes that I have myself also. We've had very hot weather out here in California this last few years, and very dry weather, very, very low humidity. And the bees avidly forage for water during the day. And the question I've wondered is, there's good research out there what they do when the foragers, water foragers, come back with their water and pass it to mid-age bees, which then move it into the hive and use it around the brood nest, is what it says so far. So I was curious about this. What we also see when I take a lid off a hive, where we break the comb below the cover, this is all water here. The bees will just cover the tops of these combs with water. It evaporates off in a couple of minutes when you take the lid off, but the top bars are just covered with lots of water, and that's how they deal with that heat there, by this evaporative cooling. So I did a quick experiment. I was curious on hot, over 100-degree weather, very low humidity, like 10% relative humidity. If you gave colonies the choice of heavy syrup, 2-to-1 syrup, as opposed to plain water, what they would do with it. And I set up a number of hives this way, and every hive just mobbed the heavy syrup. Despite it being very hot and very dry, they largely ignored the water, not completely, but largely compared to this. So they would empty this jar first, and then they would take them about a full day to take a quart or a little less than a quart of plain water down. They would take it, but nowhere near at the rate that they would take the heavy syrup. That very much surprised me. So I wondered what they're doing with this. So I set up a trial where I put in 4 dishes, and 2 of them I fed heavy syrup in, and I used red food coloring to dye the heavy syrup red. And then 2 of them, I did plain water and dyed it blue. And I sprinkled these pine needles over the top of here also to make sure that they didn't drown and the bees could come up. Left it for a few hours on over 100-degree day. This was a single, and then went back in here to see where they stored the red or the blue syrup. And in some of the combs, you can see it very easily. The red, which was always stored or generally stored next to honey, or the blue, which is only stored on the periphery of the hive, generally in empty cells, not in cells that contain any honey at all. Now, I couldn't see if there was dark colored honey or nectar or whatever in cells. So what I did is took a big pack of Q-tips and then would stick the Q-tip in, and that would show me whether it came out red or came out blue or came out with honey. It was very easy to tell the difference of them. And I did a whole bunch of Q-tips, and you can see very few of them came out with any blue. Almost all of them came out with red, the heavy syrup. Where I found was in the center of the colony, anywhere near the brood nest or near honey, it was all heavy syrup. There was no plain water stored at all. Now, I didn't have much open brood young larvae, so I've tried a few times. In fact, today I was out here working with it, trying to set up a colony with open brood young larvae, because some of the researchers have found that the bees will put plain water on the upper ceiling of a brood cell to humidify it. So I still need to test that. Where I found the blue coloring was on the outer comb. So there was outer comb of foundation in this single, and this is very typical to have the blue stain where the water had evaporated, where the bees had put it. Also, everywhere along the top bars, this is right at the top of that foundation, the edge of the top bar, on the sides and the top of the top bars, I would find the blue food coloring. So let's go back to here. So what I found was, yes, the bees do use water brought in that they gather within the hive, and they do use it for evaporative cooling. They store all the heavy syrup in the middle of the cluster, and they only put either drink the plain water, because I didn't find much of it, or if they don't drink it, then it's stored on the very outer periphery, apparently for evaporative cooling, but not stored at all in combs in honey or anything. Next thing is hive health products, and as some people, such as Blake, promote probiotic feeding. I just saw, so I get a lot of questions about that, and I'll tell you something, that as far as I can tell, beekeepers are absolute suckers for snake oils. Everybody wants some kind of magic in a bottle that they pour into their hive, and all of a sudden they're a good beekeeper, all their troubles go away. I have yet to find any magic in a bottle for beekeeping. We don't use anything in our operation. Many beekeepers are under the mistaken impression that bees like essential oils. The reality is bees hate essential oils, that they're very disruptive to the colony, and we'd be careful about putting essential oils into a hive unless you have a good reason. The thing I would suggest is when you go to the bee conventions and you have all the salesmen out there, such as this guy, and the selling stuff, ask a very simple question. May I see your supportive data of how your product is a benefit? And I will tell you right now, if they have any data, any evidence whatsoever, they will be proud to show you that data, that evidence that the colonies were larger, they were stronger, they had less disease, they made more honey. They will be trumpeting that evidence. If they're not showing that evidence, that means they don't have it. One of the things I see is there's two products that I have given unfavorable reviews on after testing them. So they responded, they both came out, and on the internet, they asked beekeepers for testimonials, and they rewarded them for good testimonials. They said, hey, send us in a really good testimonial for our product, and we'll give you a free product. Okay, to a scientist, a paid testimonial is very different than hard data. So I'd be careful about the paid testimonials. So I could test the direct fed microbials, the probiotics that are on the market. There's two of them. They have great sales pitches. And I do ask the salespeople every year for supportive evidence, and every year they smile and shake their head that they don't have it. So I took the two of them off the shelf, the Super DFM and by Strong Microbials, and then the Pro DFM by Man Lake. And then I fed a control of powdered sugar, because these are powdered sugar based. I was blinded as per treatment. I don't know which product was which. So 3 different test groups: Super DFM and powdered sugar, Pro DFM, and then straight powdered sugar, feeding once a month during a stressful time in our area, which is July through November, when there's not much food coming into the hive and the colonies could use all the help they can get. We tested it in 2 yards. One was a sunny yard right here, and one was a shady yard at a slightly higher elevation. We graded all the hives at the start and the end for colony strength by counting the number of frames covered with bees. This is my newest technician right here. This is a Ryder, my grandson, that's my son, Eric. And we started him early in this business. As I imagine Blake got started early to get him trained. And boy, I'll tell you, this guy, he is sharp. He is on top. He watches me like a hawk, make sure I don't make any mistakes. That's the kind of technician. That's why I want a technician, somebody who's just focuses to make sure we don't make any mistakes at all. I welded together a special hand truck. So this is a weighing device. We can just slide it right underneath our hives and pull down on the handle, and the digital crane scale gives us the weight within 1/10 of a pound. So very rapid weighing of these hives. And then we fed these 26 hives in each test group, feeding them monthly with color-coded jars. Nobody knew which product went to which hive, other than you match the color to the hive. Okay, so here's the data. And this is the way I like to show a lot of data. Instead of showing you means and medians and a bunch of statistics that nobody understands, I show you starting and ending. So either weight, colony strength, mite counts, very simple. And I show you all the raw data. No question on whether it's a mean or a median or significance and outliers of that. You see it all. And then the human eye is very good at picking things out of the raw data. So here's our 3 different treatments. A, B, and C. Again, I don't know which is which. One is the powdered sugar control. This is the blue is your cluster size, your starting strength of these colonies. And the red is the ending strength of each hive. So this colony grew slightly right here. This colony shrunk slightly. But if you look at all 3 groups, you can see there was no measurable difference. And students' t-test says there was no difference in here. So all I can say is there is no apparent measurable benefit to feeding either of those probiotics over feeding that tablespoon of powdered sugar once a month, other than a lot less work, not having to feed them. Okay, then, oh, I'm sorry. That was in the, I got my slide covered. That was in the shady yard. Here's the sunny yard. And you again see no apparent benefit to feeding in the sunny yard either. Then we'll go to the pounds, the weight gain. So you can see virtually all the colonies, or all of them, gained weight. The red bar is higher over that period of time. And you can see no apparent difference in the weight gain between the ones fed either probiotic or the ones fed the powdered sugar control. And that's the shady yard. And here's the sunny yard weight gain. And again, I have not unblinded myself yet because we're still collecting more data off this, but no telling that there was any benefit there. I then took samples of bees at the end of the trial in November, froze them immediately on dry ice, shipped them, which is scary during the pandemic because of shippings. It was $500 just shipping per shipment to ship these off to make sure we had enough dry ice at overnight, because there's all these delays in shipping. So I did get them to my collaborators at USDA lab, and they're doing the molecular analysis right now of the gut microbiome, the bacteria that are in the gut, pathogen analysis, virus analysis, because there still could be some possible benefit other than weight gain or colony strength. So we hope to have this data. There's a master's student dedicating their life to analyzing all these samples. Then the next thing, I still had a question with these colonies. I'd been feeding them all that period of time. I thought, well, I'll do one more experiment and answer the other question. Many beekeepers are under the impression that if they feed an antibiotic to a hive, which will kill much of the gut bacteria, that there may be a benefit of feeding a probiotic back to the bees after feeding that antibiotic. So I did that a second trial using the same hives and with the same probiotics. I treated them with either tylosin or oxytetracycline. gave them 3 treatments 4 days apart to really hit them really hard with the antibiotics. Then I waited a few days for the antibiotic to dissipate or degrade. And then I hit them again with a treatment of the probiotics. And then we sent off a second set of samples. We're going to find out whether any of the applied probiotic strains ever established in the bee guts, whether the feeding of the probiotic helps the community structure in the gut to recover. Does it affect the pathogens, and does it affect the treatment after the antibiotics? So here we are sprinkling on the antibiotics on the hives, one of the 3 treatments each. Okay, any questions on the probiotic? Anything come up?
Yeah, Randy, Stan is asking, he says, I was told by a friend that you suggest not feeding sugar water as it messes up the bee's gut. Is that true?
No, I don't make any suggestions or recommendations to anybody. I give you the data, and then you guys make up your own suggestions. Management I studiously avoid making any recommendations whatsoever. That said, I never said that. I never said there was any problem with feeding sugar syrup. We feed sugar syrup in our operation, and I've looked at the literature extensively. I have not seen evidence to support that claim. Okay.
Perfect. That was the primary question. Thanks,
Okay.
Randy.
Okay, next one. Are there some pollen subs? I noticed you mentioned feeding pollen subs, and yes, out here in California, since we have a huge pollen dearth from July through November, and we need to build our colonies up for almond pollination in September and October, we do feed pollen sub and depend upon that for our income. So the question is a very practical question that my sons ask, because they spend a lot of money on pollen sub, and many beekeepers ask, are there some better than others? So I ran a controlled trial to follow up on one that I ran in 2013, which is the results which are on my website. Oh, okay. Since my I had chemoradiation treatment for a tumor on my tongue, and the radiation fried my salivary glands. So I don't have much saliva production. So I dry up inside my mouth and throat. So that's why I'm snuffing and snorting and stuff. So we tested 6, and then there was a group of commercial beekeepers down in the Bakersfield area that make their own pollen sub from a recipe they developed with some help. And they were curious how it would compare to the pollen subs that are on the market. So they helped to fund this trial. All these trials are funded only by beekeepers. I don't take money from any manufacturers. So I had them make their pollen sub into 1 pound patties. So I call that the home brew. And I compared it to one that we've used a lot, the Man Lake bulk soft patty, because we prefer a chunk patty rather than a patty fed in paper. The reason is you can place this, more of it in a hive, you can place it right in the center of the cluster. It doesn't spread out, and it squeezes between the frames and gets closer to the nurse bees. So nurse bees use it more readily than they do if nurse bees do not like to feed on a pollen sub that's placed more than an inch away from the brood. So that's a big factor with pollen subs. Then I got a global patty, asked for their top of the line, which is their 15% natural pollen. So 15% natural pollen and global. AP23, that's a new product from Dadant. Megabee, that's a longtime product from Gordon Wardell, developed it working for USDA. Ultra Bee, which is Man Lake's flagship product. And then the new product by Healthy Bee, and I did work with them early on this. And this is a spirulina or spirulina algae, but they were adding a lot of thyme oil to the formulation at that time. And now, based upon the results of this trial, they are selling it without the thyme oil if you want it. So take that with a grain of salt, the results here. And then as a control group, I fed them patties with an equal amount of sugar that's in the patties with just sugar fondant alone between wax paper. We had 144 hives in the trial, 18 hives for each patty type in 3 different yards. Now, you can imagine that could be confusing. So before we went out, we would count the patties and put them into tubs color-coded with colored tape around there. And every hive on its on the hive number had a piece of color-coded tape. So we were semi-blinded to the treatments. We could tell that some were one color or another, but we didn't pay attention to that. We just matched color to color. We'd lay them all out on top of all the hives and then do a walk around the quality control person, making sure they all matched. And then we would open the first hive so we didn't make any mistakes. We chose intentionally yards that we knew colonies nosedive without supplemental feeding, that they would never, ever make it to almond pollination if we didn't feed them. And they're minimal natural pollen coming in, and then fed them all summer. And here's the how we worked out. We did in 2 of the yards get a very unexpected short, about a 10-day nectar and pollen flow from yellow star thistle. So we stopped feeding at those 2 yards, but we did feed the remaining 3rd yard. So orange square means we fed pollen sub at that time, and blue means we fed sugar syrup at that time. We kept enough sugar syrup and fed enough sugar syrup not to plug out the brood nest, as you mentioned before, Blake. I got the end of your talk, but enough that there was always open cells of ripening sugar syrup around the brood nest. And then we graded them for strength at the start point, the midpoint, and the end point the next February. So this is no feeding during the winter period right here when they shut down brood rearing. And we would, each feeding, we would take out any uneaten sub and weigh it so we could see how much they ate. And what we found is they did not grow. Now, these are yards that historically we could get them to grow during the summer. So I compared the temperature and humidity. This is temperature highs. These are humidity highs. This is for the 2020, the solid lines when we ran this trial. This is for the 2 years before, where in the same yard, we were able to grow the hives. And you can see our temperatures were much higher, especially in this September and October. We were up there in the 100 degrees or the 90s late in the season. And the humidities were much lower also. So I think these 2 things were very stressful to the hives, which is why we did not get much colony growth. And let's see what's this one here. So protein content. It's recommended by in the books to feed pollen subs at least 25% protein, but this is what the actual protein contents were. And of interest, of the best performing ones, Global had one of the lowest protein contents of the subs fed. And then I was curious whether the starting strengths of the hive were reflected in the amount of change in colony strength. And what we saw was if this is your colony starting strength, here's your change in strength over the season, where if they grew, they're above the one-time line. If they shrunk, they're below that. That actually the stronger starting colonies grew less or shrunk more than the weaker starting colonies. The weaker ones tended to grow more. So colony strength, this is just me double checking to make sure that there was, because we intentionally did not equalize all the hives. We intentionally wanted to have a variety of strengths of the hives. But in each treatment group, we did a stratified block design so that we had colonies of the same range of strengths in each treatment group. Okay, so then this one is, so here's our main colony strength at the winter strength and the global patty and home brews. And these were not huge colonies. And this was graded in a very cold snap. So very cold weather, they were down to 6 frame clusters, which in that temperature, that was adequate to make it to the winter and build up in the spring. But you can see these 2 were definitely the standouts there. Unfortunately, a healthy bee with all the spirulina, the bees just did not like that patty, and it barely did any better than the plain sugar controls. Then we of those samples, had sent them to the lab. They dissected the bees and then dried the heads and thoraxes and weighed them. And what you can see with the on this side, this is your head and thorax mass in the left-hand column. And in the right-hand column is the total frames of bees per group, so your average colony strength. And you can see there's a direct correlation between the head and thorax mass and the number of frames and bees. So that was a very good indicator of the success of feeding these pollen subs. And as you can see over here, the poor healthy bee was pretty sad to see right there. But again, the global, the bulk soft, and the home brew coming out very good up here. Then here's what's interesting. this is the gut community structure, because I was curious whether feeding pollen subs, 2 of them had natural pollen in them, and the rest had no natural pollen at all. I was curious whether the gut microbiome, the 6 main groups in the gut, whether they require pollen as a substrate for growth, as a prebiotic, as opposed to a probiotic. Prebiotic is the food for the gut bacteria. And I would have hypothesized that you'd have better community structure of the gut bacteria in the ones that had natural pollen. This one here had the most natural pollen. This is 20% right here. This one had 15%, and none of the rest had any natural pollen in them at all. So, and you can notice the community structure of the different bacteria is identical for all of them. And the bacterial abundance was one of the least for the one with the highest amount of natural pollen in it. Just exactly what the opposite of what you might expect. This indicates that you don't need any natural pollen in a pollen sub to have the proper community structure in the gut, or to have a large amount of the beneficial bacteria in the gut. So that was a surprise to me. We also had some hives in each group that were potential breeders. So we had not treated them with anything. We treated all the rest of the hives with some oxalic acid, extended release, to keep the mites down. So there were some that had not received any treatment. I thought, hey, let's have these analyzed separately and see whether oxalic acid appears to have any adverse effect on the gut microbiome. So these were the oxalic acid treated bees, 81 of them. And these were the 8 non-treated. And you can see the gut microbiome looks just fine in the oxalic acid treatment bees compared to the not treated ones, or to the treated ones to the not treated ones. Okay, so here's grading before almonds after 7 months of artificial diet. And the standouts, this is the total number of frames of bees that we could rent in almonds when we combine them for all 18 hives, I like to grade by what puts money in your pocket. This puts money in our pocket right here. And if you look over here, there's 3.5 times as many bees in the home brew group than there were in the sugar control. So this shows you the benefit of feeding that pollen sub to grow these up. And again, the 2 winners were the home brew and the global right here. Now, the big question is why? Why were they better? And the first thing you might think is because they have natural pollen in there. But that is not, I'm not at all convinced by that. And if I'm publishing articles in Bee Journal telling you why, you can follow that. This research, the state of the art in bee nutrition, as far as the amino acids, is all based upon this research right here by Antonius de Groot, published in 1953. I don't think you were around back then, Blake. This is the state of the art of our knowledge on amino acids in bees. We are so far behind the rest of the livestock industries. It's absolutely pathetic. The second thing is this document, this paper, and de Groot did this incredible study. I have no criticism whatsoever. Nothing but admiration by the meticulous work he did. But I feel this is 80 pages long, very heavy reading. I doubt there's very many researchers or beekeepers who have studied this document in full. I have spent many, many days studying this, and I think it's largely been misinterpreted, both by him and by other researchers. And what he did is he took caged, newly emerged bees, put them into cages, and then fed them an artificial diet of sugar and purified amino acids, essential amino acids. And then he fed them at different concentrations. That's a 1% of the diet, 2% of the diet, 3% of the diet. And he looked for the inflection point. So this shows that you got more growth with 2% rather than 1%, more growth with 3% rather than 2%. But after 3%, you didn't get any more growth. So then he could figure out what percentage minimum you needed in for each one of these essential amino acids. And he published a table, table 25, which has been widely cited. And what I showed here is a graph for each of the different pollen subs. This is de Groot's recommendation for the minimum amount that we need in the diet. What people don't read is in the next paragraph, de Groot said, but this was not for optimal growth of these bees. These bees did not grow very well. This was not an optimal diet, but this is the bare minimum amount. So right now that tells you that this number is too low. But when I compared all the pollen subs to this number, you can see none of them appeared to be deficient. None of them had a level of this amino acid below that, that right there. And this is when relative to tryptophan, which is what de Groot used for normalization. And that was a big mistake as far as I'm concerned, because what you look right here, you can say, well, they all look good relative to tryptophan, or you could look here and the thing that jumps out at me, but they look like they have way too much tryptophan and way too much leucine, which means that if you correct for these, they probably are deficient in other amino acids. So I need to reinterpret this research. And what I did then is I created a calculator that anybody, anywhere in the world can download this free calculator. I'm going to put it online soon. You can put in your amino acid, you put in your pollen sub formulation, and you put in the raw ingredients and put in the proportions, and it instantly calculates your essential amino acids in the green columns relative to de Groot's recommendation. But instead of normalizing to tryptophan, I normalized to leucine, which is the predominant amino acid. And since that's the main amino acid, to me, I want to see what you're deficient in relative to leucine, because once you're deficient in the amino acid, you can't use any more leucine, which is the main amino acid. So that's where de Groot made a little mistake. And this is and what we found was for all these patties, they were all deficient in valine and isoleucine across the board. Some of them a lot. So look at, this shows how much deficient megabee is in valine. This is the limiting amino acid in megabee by a long shot. Same in the bulk soft, same down in the healthy bee. Now, for comparison, let me see what I got here. Oh shoot, I don't have the. Okay, I should show you for the royal jelly. Royal jelly, they match almost perfectly. Natural high quality pollens, the green bars match almost perfectly. So we have really good confirmation of de Groot's findings. So I have now sent to each of these manufacturers that I had their formulas all analyzed, and I told them exactly how many ounces of each essential amino acid they would need to add to a 100-pound batch if they wanted to make their diets appear to be perfect. And the evidence for that is this. I then plotted, I looked at all the essential amino acids. I said, well, which ones are deficient relative to leucine? And I added those up and I said, this is your proportional deficiency to leucine. So this would be no deficiencies over here. And the worst ones scored negative 3.5 deficiency. This is your ending number of frames per treatment group, with the homebrew and global scoring the best, the healthy bee scoring the worst. But look at this correlation coefficient. In biology, you never get a correlation coefficient of 0.85 unless you have causality. That this is really means, wow, you're onto something really, really serious when you see a correlation coefficient of 8. This means that my calculation here explains 85% of the variation of these right here. So this is this may not be a $10,000 bet, but boy, this is really easy, $100 bet right here. That if these guys down here just looked at their deficient amino acids, they could maybe make their formulations perform as well as these up here. So we'll see if they follow up on that or not. They've all gotten the information. Pretty soon I will have that calculator. If anybody wants to email me now, I can give it to you. But you can, if you make your own pollen sub, I can show you how you can possibly improve it by balancing your essential amino acids. Okay, now we need to get down to the nitty-gritty here, because what time we got now here? 5:30 now. We've got another half an hour, so we can go on to probably either extended release. Oh, you know what? I can show you thermal treatment.
Yeah, Randy, I think thermal treatment would be awesome. And then we had a ton of people asking for the extended release OA as well. So,
and yeah, that's popular. Here's the take home right here. My tips for mite management. Understand that Varroa is only the vector. Varroa is not what kills your colony. It's the viruses that do. So, oh, you guys are in Texas, so you don't wear any masks or get vaccinated down there. So you don't understand virus pandemics, okay? Those people who do understand virus pandemics, yeah, you want to avoid transmission of viruses from one person to another. And that's what you do with Varroa control. You're minimizing the vectoring of the viruses from one bee to the other. So monitor your mite levels, but the main thing is keep your mite levels down all season long. Don't let those viruses climb during the season. And the key take home is that the mites reproduce most rapidly in the springtime. So nip them in the bud. Let me go through. Here is your daily rate of mite increase, relative increase, not absolute increase, but absolute increase is total number of additional mites per day. This is your mite reproduction rate, how many daughters there are per female mite per time period. And if you look at it, it's very much the highest right at swarming season. So this is when you want to nip the mites right here before swarming season, early in the season, because by this point they get ahead of you and you have a very hard time catching up the rest of the year. So nip them early in the bud. Okay, let's go down past all this stuff here. Okay, thermal treatment. Okay, this is good for the treatment-free beekeepers who don't want to treat their hives. And theoretically, if you get it hot enough, you can kill the mites. And the reason is this right here. I can move this around. This is the column for Varroa of temperatures. This is in Fahrenheit. This is a column, this is in centigrade. And this is for the honeybee. And so at 160 degrees Fahrenheit, mites really are seriously stressed and they start to die rapidly here. With honeybees, they're not very stressed right here. They don't get into danger until way up here. So you have this sweet spot here where you can really hurt the mites before you start hurting the honeybees. And Mike Emer showed me some data from thermal treatment that looks really, really promising. So I followed up on it and did some thermal treatments of hives. And they do with this device where they are free to, some devices keep the bees inside, some let them come out right here, but no noticeable adult mortality of the bees. I put in 2 thermistors inside to make sure that the airspace between the combs and the upper box, and it's double, did reach the 106 degree temperature and hold for 2 hours. And then one of the thermistors was pushed underneath between cells of sealed brood down to the midrib to make sure that that heat penetrated for those hours all the way to the bottom. And yes, it did. So I did confirm that we got the heat penetration. And then afterwards, I went in and I dissected at 24 hours and some at 48 hours, the brood out, the sealed brood, the pupae and propupae, and then looked at the percentage of mice that were alive or dead. This plate where I'm dissecting a patch of drone brood in the upper box, all these mice were happily running around afterwards, did not harm them noticeably at all. And what I found is in the drone brood, only one point did I find in one thin line of drone brood at the bottom of a top bar where they're more dead than alive. Everywhere else, that's the number of live ones to dead, 34 alive to 3 dead, 12 alive to 4 dead, 40 alive to 8 dead. And the worker brood, 22 alive to 2 dead, 9 alive to 1. Obviously, we did not get, and this was at a 48-hour treatment here. So, or check back. So we didn't kill all the mice. So, but then the proponents of this said, well, it sterilized the mites. So here's your mite wash number of mites. And I used high mite hives here. It did drop at 24 hours. It dropped further at 15 days. Now, if those mites had been sterilized, this lines would keep going down because you wouldn't have reproduction. But as you can see, they were very sterile and mites were able to rapidly reproduce again. So still needs some work to do. What I did do is I created this table here, this graph showing the two temperature curves. So this is the temperature curve for the mites. Anything above temperature above this temperature and above this number of hours of exposure will kill the mites. Below this temperature or this number of hours of exposure, the mites can survive. This curve, the green one here, is tolerable by the bees up here, or above it intolerable to the bees. So the sweet spot is where the two of them cross. And the thermal treatment I used was either a little bit too cool or a little too short duration here. So they have to adjust this. So this is a benefit to anybody who wants to work with thermal treatment. Use this chart, and that will, or this graph can tell you what combination of hours and temperature you would need to affect Varroa kill without killing the mites, without killing the bees. Another one. Anybody using oxalic acid vaporization in Texas there, Blake?
Yes, a lot.
Okay,
Yeah,
a lot of people.
folks.
It's funny. Different areas, it's popular, and people, they love it because you never have to open the beehive. Who in the world would want to open a beehive? You can just stick it in there, and then people think, oh, well, the faster I do it, the better. So they got these smoking hot ones, which shoot in there, not even allowing the cluster time to open up and allow the oxalic acid to penetrate. But because the beekeeper sees the fog coming out, they think they've done something. I've done tests myself, but I replaced them this week with some data set I got from a beekeeper from Washington State. He vaporized every 4 days. Every triangle is a vaporization every 4 days. This is his daily, this is his mite fall every time he checked right here. So you can see after 6 vaporizations, he was still getting the same kind of mite fall he got early on. It took him 1, 2, 3, 4, 5, 6, 7, 8 vaporizations 4 days apart before he stopped getting a mite fall. And then he waited for a few days and vaporized them again. Bingo, the mites are back up there. Took him 1, 2, 3 vaporizations again to start getting him down there. This is a lot of vaporizations. This tells me anybody who's thinking you're getting any kind of high efficacy when you have brood in the hive with vaporizations, you're dreaming. This is it's a pipe dream. It's not happening. Okay, so let's go down to oxalic acid. And I'll tell you right now, I'm the only beekeeper in California who legally can apply oxalic acid to a beehive for Varroa control. If I were bleaching my top bars, that would be legal. But at the moment my thought bubble involves the word Varroa, I would be breaking a beekeeper would be breaking their law. So I am not, and this method is not yet approved by the EPA. So I, Randy Oliver, in no way promoting that any beekeeper do this. I am simply, since my research is funded by beekeepers, I am giving a shareholders report on what I have learned in my research. Okay. So I'm going to go past all this. This is summer treatment. Let's go down to the oxalic acid. Perhaps formic acid. Oh, hop guard. I didn't show the results last year of the test for the hop guard during the summer because the label was hard to read. I'm not the only researcher who misread the label, and now I've worked with the manufacturer. They're going to change the label and put it in words that actually are understandable by the beekeeper. If you're going to use it while there's brood, you need to repeat the treatments. But there was a question with the manufacturer. They didn't know how often the treatments should be repeated. So I just did a trial on these, and we were curious whether it would be better to treat them every 7 days or treat them every 14 days. So that's what I did. I set up colonies, 7 in each of these test groups. And so 7 colonies got treatments at 7 days, 7 of them got treatments at 14 days. And I took mite counts at the start at day 21 and then day 42. Now, I did make maybe a mistake in this trial because we were looking for some high mite hives. And I asked my sons where in the operation we had some high mite hives. They said, Dad, we don't have any except for what you got at home. And I said, well, those are all our breeder queens. And the only ones with high mites are ones that we rejected in the second year because their mite counts were going up in their second year. They weren't holding 0 mite counts anymore. I said, well, I'll use those. That may have been a mistake. So I applied the Hop Guard 1 strip for every 5 frames of bees, and generously, if there were 7 frames of bees, I put 2 strips in. Very minimal bee kill, even though if the strip touches a adult bee, it will die. We didn't see any queen loss, and I didn't see the amount of dead bees in front of the hives as I used to see with Hop Guard 2. This is Hop Guard 3, so they've changed the formulation, so it's easier on the bees. I wasn't treated in hot weather, so you can see most of it's up around 90 or above during most of this trial right here. And what I noticed is when I put them in with the treatments strips for every 5 frames of bees, when I came back afterwards, they often had moved away, the brood nest away from the strips. But then after they started brooding up again, I would often see they would come back. So this is kind of a spent strip, and they would brood on either side. Some of them, though, had brood right under the strips, okay? Okay, again, blue and red. Blue is your starting mite count. Red is your mite count at day 21 right here. And you can see with the control group, the mite counts all went up in the control group, and they all went down in the Hop Guard ones went down about equally on the 14-day application, which only had 2 strips put in, or the 7-day application, which would have had strips put in 3 times. So strips put in twice, 3 times. So 14 days seems good. I'm showing you the results at day 21 for a reason, because at day 42, the control hives, all their mite counts started going down on their own. So that means that really screws up the efficacy calculation. And that was the mistake I made of using potential resistant bees in the control group, because when I looked in them, they were exhibiting very strong uncapping, recapping behavior and Varroa sensitive hygiene. So they said, oh, that's enough for you mites. And they started knocking the mites back on their own. So our efficacy calculations, this is at 42 days, not that good, around 70, but we got above 80% efficacies at day 21. So that's definitely doable. So Hop Guard is an option when there is brood during the summer in hot weather with honey supers on the hive. Okay, so now let's take a look at the Oxalic. So this is the shop towels that I was using originally at start and end point. And you can see they didn't do that well, the shop towels. One of the problems is I started with low mite hives in this group. You get better efficacy if you start with high mite hives for some reason. I don't know why, but that's just the reality. With using 1/2 of a sponge of a cellulose sponge, the more blue you see, the better the mite treatment. The more red, the poorer it is. So we still saw a lot of red using 1/2 of a sponge. When we use 2 sponges, we see a lot of blue and very little red. So much better right here. Let's skip that one. And what we saw here, even with the 2 sponges, look at that brood pattern. This is at the end of the trial. The bees do just fine. Because I was concerned about, acidifying a hive, whether it be harmful for the bees and brood. We're not seeing that. But here's the key thing. Those outliers, go up, right here. The question is, were they from failure of the treatment, or were they due to drift of mites from other hives around? What we had was 4 yards that had no other hives, wild hives or managed hives within flight range. So these were all monitored prior to us moving in. 3 of them in the High Sierra, where I was working with some grad students that were looking at the pollinator interactions, and they confirmed that there were no honeybees at all until we moved bees there. The other one was up in isolated valley in Nevada, where we go for a pumpkin pollination. There were no honeybees at all until we moved bees in there. And here, in those locations, both of them, instead of being in a dearth, they made honey and they reared drones like crazy. So the mites should have gone up much higher in these hives. What you can see, the mites went down quite a bit, especially when I put the full sponge in, the 50-gram treatment right here. if you don't see a red line, that means the mite count, Indian mite count was 0 mites. These guys went from a count of 40 mites, count of 50 mites down to zeros. These other 2 yards, look at what they came back with. When Eric I was taking the samples from these hives when they came back, and he's doing the mite washes. I said, "Hey, Eric, how's it going?" He said, "Dad, I've never seen so many zeros in a row." This is incredible, that completely knocked out. So this is telling me those other outliers that we saw, that's mite immigration coming in from elsewhere. We got even better results from the pumpkin patch. I didn't record the data on that coming back. They all came back just zeros across the board. So mite immigration is the problem with this oxalic acid extended release. I'm going to skip through here because, okay, well, we did a bunch of hives with only putting in a single treatment last year, a quarter of a sponge, and they kept mite levels low until September. So we tried an experiment this year. Okay, take home. Oxalic glycerin is a long-term treatment, appears to work best in yards where there's little mite immigration. Okay, so that's pretty much the end of here's some more interest. There's different formulations, ratios used of oxalic acid to glycerin. So this is the Argentine ratio of 2.5 parts glycerin by weight to 1 part of oxalic acid. Makes for a really oily looking treatment. And this causes the bees to be agitated, beard up in front of the hive, and you can get some brood loss here. So this is a bit of a too strong treatment. We use the 1-to-1 by weight formulation. We've been using it, have been using it. We like the handling characteristics better. The other thing is that we're seeing is this is different oxalic acid glycerin treatments I put in that you, this is your mite drop per day. So this is the baseline, this dotted green line. When we put in the treatments, after a couple of days, that your mite drop increases tremendously. And it remains above baseline for about a month before it starts to drop down. So it's a long-term treatment before you start getting this, this mite drop dropping down. The other thing is you would expect if you're dropping an elevated number of mites, this is 15 times baseline here. This is 5 times baseline, even at day 10. If you're dropping all those mites every day, what do you think, Blake? I mean, when you're dropping that many mites, what would you expect to see with the alcohol washes or detergent wash?
Yeah, you wouldn't think you'd see a whole lot.
Right, you think that would go down. Here's the baseline for the alcohol washes. They go up for 30 days. Yeah, that's what I did. Shake your head. What the heck are we seeing here? The only explanatory hypothesis that I've been able to come up with is that it's inhibiting the mites from re-entering the brood cells. They come out, but they don't go back in, and then they drop off. And what you get is finally after a month, by that slow attrition of them not reproducing, your mite counts drop down to 0 by 2 months. So it may not be the killing of the mites, it may be, well, not only the killing of the mites, but it may be the inhibiting their ability to reproduce for some reason. I don't know what that is. So this is yet to be determined. The other thing was how much was actually released. We put 2 sponges held 50 grams of oxalic acid. But when I took the old used sponges out of here and then calculated the weights, only a tiny bit of the law of was actually used. So on these half sponges, we started with 25 grams of oxalic acid. We only had 4.5 actually get out onto the bees. So what it is, it's surface area rather than how much is in the sponge. How big is surface area? So 2 of these had enough surface area to give good efficacy. One half sponge was not enough. So now let's move on to some trials that we've done this spring. Instead of cutting these sponges in half, we cut them in quarters instead. So now we can fine tune this. Oh, the other question, is there a difference where you have high humidity? And what we found was in Virginia, no, they did well in Virginia. And in Yucatan, we have this tropical jungle. they do just fine there, very high efficacy. So humidity is not an issue with them. The other question I had, is there a better matrix? Okay, so we have a bunch of different ones that I'm using here, cellulose, or cotton facial pads. There's the Swedish sponge. This is called a maximizer industrial pad. This is cardboard. This is the Swiffer pad. This is acrylic felt. And this is another fiber wipe right here. I put masking tape over the top bars, and all of these are exactly the same surface area. And then I left them in here for 20 days and weighed them before and after. Oops, I thought I showed the data. The data shows that most of these either were a pain in the butt in the hive, or they didn't release enough. So the Swedish sponges and the maximizer pads were the best. These are less expensive and readily available by quantity anywhere in the United States, whereas these are expensive and hard to get in quantity. So we've been using a lot of these maximizer ones this season. And the thing I'm wanting to do is to get back on this here. I've had this set up for well over a year now, and I'm just slow on it. I have a titration setup where you put 5 milliliters of water in a test tube, add a couple of drops of the indicator solution, and then if you drop in any oxalic acid, it'll change it from blue to orange. The amount necessary to get good efficacy to kill mites is this color right here. So I dropped this bee, and this shows that this bee from a treatment had enough. And then what I do is to quantify the amount of oxalic acid, I drop in a titrant, 1 drop at a time, until this turns back to blue color again, to starting color. And at that point, the number of drops, I can tell you how many micrograms, how many millionths of a gram there were on that bee. And this is amazing. You take this out, sit next to the beehive, and plop these bees in. It takes 15 seconds a shot. And if I only had 15 seconds in my life to spare, I would be doing this here. But I'm hoping before winter to get out and just do this and test the vaporization. Because when I did a vaporization test, I couldn't find any oxalic acid on the bees at all. Oxalic acid dribble, bam, they turned it yellow. So I want to test the different application methods. We do carry baking soda at the rate of 10 heaping tablespoons per gallon with us all the time to neutralize any acid on our hands. This works also for formic acid very well. So always carry this. We use kitchen tongs to handle this, and with just lightweight gloves. EPA says you have to use a very heavy glove. So yes, follow the label. The label is the law. But lightweight gloves work really well too. So these are the sponges cut into quarter strips right here. Very easy to make. Okay, now this just happened. EPA just created an exemption for the requirements of oxalic acid in the hive. So there's an exemption now, which means now it can be approved for use while the honey supers are on. So nobody's followed up on this yet. So some manufacturers got to do this, or I just wrote to a friend at EPA saying, can we get an exemption like they have in New Zealand? New Zealand has a personal use exemption that the beekeeper himself can make his own oxalic acid, and it does not count as a pesticide application, and they're free of any kind of legal restrictions on using that in the hive. I would love it if we could get that in the United States, but it's going to take pressure from our industry, and so far neither the AHPA or the ABF has been stepping up to the plate to put that pressure on. So if you want to put some pressure on them, maybe we can get this personal use exemption, because they already have the example in New Zealand. It would be very easy to do. Then I had a beekeeper ask me, well, is there any evaporation of the oxalic acid? I said, I doubt it, because the vapor pressure is too low, but just because I doubt it doesn't mean anything. So I ran a quick cage trial, putting some high mite bees into 2 cages, a test cage and a control cage and incubator. And this, I put crystal oxalic acid underneath this screen and no oxalic acid, left them in there for a few days. And there was no mite drop whatsoever from in either of these cages. I washed them afterwards. There were mites in there, but the crystal oxalic acid did not, there was no vapors coming off this causing any mite drop at all. The question now, are there better matrices than the Swedish sponges? And I showed you this one already. Well, here we go. So I looked at the amount of weight loss after 20 days in the hive. And the only ones that had a much release were the maximizer pad and the Swedish sponges. The Swiss cotton worked well, but it was too awkward to be practical for use. Too time consuming. So I cut that out. We also tried the acrylic felt because it was so easy to make, even though it had a small loss of the oxalic acid glycerin in the hive. We did try a trial and we kicked this out very quickly because it didn't control the mites. So the two that did control mites were these two right here. There's us making up the test. The cotton pads, I was hoping that these would shred it and then pull the shreds through the hive and distribute it. They did not do that. Okay, so the experiment we did, we put anywhere from 1 to 4 strips per hive of either the Swedish sponges, these are Swedish sponges, or the maximizers, or the acrylic felts. And here's the results, which I just worked up. So we did a starting count in the blue, ending count, day 55. You want to see blue, you don't want to see red. So we did low mite hives. Notice the blues, all the low mite starting counts. So these had fewer than 5 mites in a mite wash. And 1 strip didn't work, too much red. So even with a low mite hive, putting in a lower dose did not work. It works somewhat with 2 strips, which is what we found last year. This would be the equivalent of the half sponge right here. And this is for the Swedish sponges. 3 strips, pretty good, mostly blue, very little red. And the one very high mite hive that had 4 strips put in went from high mites to 0. So this is telling me you really need to have that equivalent surface area, the 56 square inches of a Swedish sponge to get very high efficacy. For the maximizer pads, pretty much the same, although at these low, lot more red, these low doses. But once we got up to this high, we had a 30 mite hive, went down to 0 again with the 4 strips. So that's the same surface area seems to be good. So today I actually just made up a whole new batches of 4 different formulations. We'll put 4 strips on using a microfiber cloth also, and then 2 different ratios of oxalic acid to glycerin on the maximizer pad. So I hope to have more data. I might wash 36 hives today, so 32 hives, so that'll give us enough to start on this. So hope to get a results on this soon. Take home: a full Swedish sponge holds 50 grams of oxalic acid in the 1-to-1 formulation, which seems to work well. It's 56 inches of substrate, so that seems to be a critical amount of surface area you need to have. The IU and CAP, the Argentine formula, have a much higher ratio of glycerin, 2.5 to 1, but it also takes, they recommend 80 grams, or I found you needed 80 grams for double deep. We're only putting 50 grams in of oxalic acid. So they're putting a huge dose in, which I find is rough on the bees. So we're going to try in New Zealand, they're doing a 1 to 1.5. So that's what we're trying right now. Because the high glycerin releases the oxalic too fast. So we need to do more experimentation, which is what we're doing and working on that today. All my research is supported by donations. These are some of the donors, and I appreciate the donations. And let me see how we're doing where'd my clock go here? I gotta get a clock here. I got time for some questions.
Yes, it was perfect timing, Randy. There has been a steady stream of compliments and thank yous, and as well as a steady stream of questions. I can just hit some of there's no way we could get to all of them, but I'll hit some of the high points.
Okay, hang on. Let's try to stop our share here so I can. There we go.
There you go. Perfect. Okay, so someone asked. Let me see. They said a lot of the maximizer pads have flame retardants in them. Is that of any concern?
Maximizer is a brand name, and I haven't checked that. That's interesting. It doesn't say flame retardant on the package anywhere. When we hang up, I got a cigarette lighter in my pocket. I got a bunch of maximizer pads sitting out there. So I'll tell you what, Blake, if they don't burn, I will send you an email.
Perfect. We'll get that out. Someone asked, they said, in regards to heat treatment, are we concerned about queens and how hot the queens get? Because I know queens getting too hot in shipment is a concern. So is that a concern in thermal treatments?
Absolutely. And the concern is not necessarily for the queen, but for the sperm stored in the spermatheca. Even an hour exposure can make those sperm go sterile. Now, when I talked to Mike Immer, who did the heat treatment, he said he didn't think he had issues with queens, but that is definitely something to be concerned about. Good question.
Yeah, fantastic. Someone asked, Randy, is your Formic Pro data available online?
Yes, that's all published now.
Perfect. Someone asked, Randy, I thought hop guard should not be used in hot summer weather over 90 degrees.
My data says otherwise.
Perfect. And they may have been thinking Appa guard.
We were right around that 90 degree. So at 90 degrees, I saw here, one thing I noticed is the colonies that got treated tended maybe to reduce in strength just slightly for a few weeks, but then once the treatment, after about a week of the hop guard being in there and takes the pressure off them, then they would resume brood rearing. And the ones where I did the 3 treatments a week apart, then they had 3 weeks to recover before my final inspection of them. And boy, they came back looking with lots of brood then.
Perfect. Okay. Mike asks, he says, they ran some experiments using the OA on the Swedish pads, the Swiss pads, Swiss sponge. And they asked if it's natural for the sponges to break down for whatever reason after a few months. They were seeing the pads kind of break down and break apart.
Yeah, they're good for 2 months. And then I'm only in a few yards, and it's interesting. 1 yard the pumpkin patch brought them back after 77 days. And a number of the hives, they had actually broken down enough that the bees were starting to remove them. Normally we get them out of there before then. And while they're still strong enough that they're easy to pull out in one piece.
Perfect. Fantastic. Well, we're a couple minutes past 8, Randy. I want to be respectful of your time. There are more thank yous and compliments than I could count in the chat box.
Okay.
Everyone
thank you, everybody.
Very appreciative. And I did want to mention to everybody, Randy mentioned that he's funded by donations, and you can see the website URL behind him there, scientificbeekeeping.com. And if you want to see more of this research, go, there's several hundred of you on, go donate and help fund that research.
Great, thank you.
So thank you, Randy. I mean, I know you're a busy guy. We really appreciate you speaking with us tonight.
My pleasure.
All right, perfect. All right. Thank you, Randy. We'll see you around.
All right, take care.
Right. Thanks, guys. And that's it for tonight, folks. So with that, we're going to go ahead and shut down the webinar, and we will see all of you guys in October, and we'll talk about getting our bees ready for winter. So with that, guys, if you have any further questions, feel free to put them in the Q&A box. Feel free to email us at help@texasbeesupply.com, and we can answer them or get in touch with Randy to get those answered. And we'll see you guys in October.